The objective of this project is to apply what we have learned in our course of trigonometry and introduction to statistics in a real-life situation. In this case, to calculate the height of an object and a building by combining the technology we have available with all the knowledge that we have learned during the last weeks about the law of sines and cosines, so that we can obtain and calculate the data we want on our own.
In this part, we show the entire route that we made towards the flagpole. We stopped at the Esplanade to take some measurements of the building and then continued on our way to the flagpole.
We are going to measure the angle that is here. Well, it's actually of 90 degrees, so we actually have this angle. What we are going to do is measure the distance between this point and that point. And we are also going to measure the angle that this point makes with the top of the post, so that we can calculate the height of all the posts.
We're going to use this app that calculates the inclination of the phone, and we're going to point it to the top of the pole in order to calculate its angle.
Now we are going to calculate the measure between here, that is under the building, and from this point here. And then we are going to use the same app that we use in the post, so that we can measure the angle between this point and the top of the building, and so that we get all the necessary data to calculate the height of the building.
By using some phone applications and some tools, we obtain the following measures. We measure the height of the main building by having a distance of 17.55 meters between us and the walls of the building. The angle between the walls and the ground was 90 degrees, while the one we calculated was 43.47 degrees. To calculate the height of the flagpole, we had a distance of 3.18 meters between us and the pole. The angle between the pole and the ground was 90 degrees, while the one we calculated was 81.9 degrees.
So for this project, we have to get A, the height of the school, and B, the height of the pole. So for getting those heights, we have to calculate with the value of C angle and the value of C. So we use the law of sines. That is this one, that A between the sine of A equals to B between the sine of B, and C equals to C between the sine of C. So we got this rule. We apply it here. We get A between we have the value of the angle of A. So we put A, that is the value we don't know, and now we get sin of 43 equals to the number of C, that is 17.55, between sin of 47, that is the value of the angle C. So now we do the calculation, and the answer is A equals to 16.36. 16.4 approximately. And now you're going to explain the other.
Well, we are doing the same thing here. We have the measure of this side, and we have the two angles beside the 90 degrees angle. So we are going to apply the same law here. So B is equal to 9. And now the value of B is calculated by doing 3.18
Multiplied by sin of 81 divided by sine of 9. This equals to,
and this equals to
9.
20.80, no, 20.07.
So these are the two heights that we got. The height of the campus is 16.4 and the height of the pole is 20.9. Thank you for your attention.
After finishing the project, we were able to apply what we had seen in class in a more everyday aspect. We were able to calculate the height of the main building and of the flagpole by using only a few applications and some calculations. We translated our knowledge from just some theoretical problems into a real-life situation where the laws of sines and cosines were actually needed. This proves that, even though it may not look like it at first glance, the theory you learn at class, it actually helps you on things that may be needed on the daily basis, depending on the situation and on what you're working on.